Now, I've kind of shown you a couple of applications of matrix, like where matrices are useful. The first being with this sheet, okay, when I first taught you about matrices, this is how I introduced it to you, okay. We've also looked at an application using transformations, okay, so if you have a set of coordinates or a shape that you want to transform, for example, you want to rotate it by 90 degrees, then we can also use matrices in order to do that as well, okay? So for example, if you want a computer to do that transformation for you, then you would use a matrix in order to do that, okay? This is the third and final application of matrices that I want to show you. It's to solve things like this. Now we recognize this, right? What's going on here? Where have we seen this before? We've got x plus 2y equals 15 and 2x minus y equals 0. Where have we seen this before?
It's a like system.
Exactly, it's a system of equations or simultaneous equations, okay? So, we know how to solve this, hopefully, okay? We've looked at this, in fact, so hopefully you might sort of try and make the same number of x's or the same number of y's, use elimination, yeah? Or you could set y equal to 2x from this second equation and then substitute it in. So we've got a couple of methods that we could use. You might even want to solve this graphically as well, so drawing these as two straight lines and seeing where they intersect. But I'm now going to show you another method in order to solve these, okay? And in fact, if you plug this into a computer, this is how they would solve, this is how the computer would solve it, okay? And it's using, guess what? Matrices, okay? So here's what I want you to do. Can you see that there are coefficients on the left-hand side? Okay, so the coefficients, remember, are the numbers in front of the x's and y's. Now, really important, okay, really important, you need to make sure that the x's and the y's kind of match up with each other. Otherwise, this won't work. So you see here, I've got the x first in each equation and then the y, okay, and they're all on the left-hand side, and then I've just got numbers on the right-hand side. So in other words, if you're going to solve this using matrix or matrices, you need to make sure that they're set up like this. Okay, that's the first thing. Now, here's how I set up my matrix. First things first, I create a coefficient matrix. So a coefficient matrix is just simply using the coefficients on the left-hand side and writing them in a matrix. So for example, that coefficient is what? It's 1, isn't it? The coefficient is 1, good. So I put a 1 there, okay? What's the coefficient here? 2, so I put a 2 here. What's the coefficient here? So I put a 2 here, and the coefficient here? -1, good. So I put a -1 there. Is that okay? So that's the first matrix that I'm going to create. It is just simply the coefficient matrix, okay? Very good, okay. Right. The next thing I'm going to create is a matrix, if you like, but you would probably call this a vector, because of course a vector is just a one-dimensional matrix, so either one column or one row, okay? So this one is going to be my variable matrix, okay, or my variable vector. So my variables going on are x and y. So I put an x first, then a y. It's got to be in that order, okay? So if I had y first, then x, I'd put y first, then x. So it's got to be matching the order of what's happening in your equation, okay? Then I'm going to set that equal, to my answer vector, if you like, my right-hand side vector on the right-hand side. So in this case, I just have a 15 and a 0. 15 and a 0, okay? So are you happy that I can extract this and write it as matrices like this? Are you happy with how I've done that? Yeah, okay. Now, just pause for a second. Are you happy that this is the same as this? How could I check that this is the same as this?
Multiply.
Yeah, multiply out. So I'd have 1 times x, or just x, plus 2 times y. Okay, so I'd have 1x plus 2y. Okay, and then I'd have 2 times x minus 1 times y. Okay, so this is like a one-dimensional matrix. And haven't changed the right-hand side. And can you see that the top row, that element there, must be the same as that element there because there's an equals in the middle. So this matrix has to be the same as this matrix. Therefore, that has to be the same as that. So x plus y must be the same as 15. And also that must be the same as that. So 2x minus y must be equal to 0. 2x minus y must be equal to 0. Does that make sense? Are you satisfied that that is literally the same as this? Okay. Good. Fantastic. So My question is, what am I after? I'm after x and y, right? What I would love is just to have x and y on its own, and then that's equal to some number here and some number here. Because then I could read it off. I could just say x is equal to whatever goes here, and y is just equal to whatever goes here, because these two things have to be equal to each other. That's what I'm after, okay? My question is, how do I get from here to here? Any ideas? How do I get from here to this point here? So how do I turn something that looks like this into something that looks like this?
Like we need
Multiplication. Go on, Rashad.
Yeah, like we need like 15 and 0 and 1, 2, 2, 1. Do one thing, no?
Okay, so you're kind of thinking about I like your idea, Benazir, as well. You're kind of thinking about multiplication going on. Have a think about this. This is my parallel just with ordinary numbers. I've got 3 times by something that I don't know is equal to 12. Let's check that with this. I've got some number, if you like, a coefficient, times by something I don't know, that's my vector I don't know, that's what I want to find, is equal to my answer. So if you like, the 3 corresponds to that. Let me colour code this. The A corresponds to that. And the 12 corresponds to that. Is that okay? So 12 corresponds to that. Okay. Now, if I was giving you something like this, how would you solve it? How did you solve it? You divided by 3. Now, just remember, we're not allowed to do division with this matrix. We're not allowed to do this division with this matrix. So what else could you do with multiplication?
0 divided by.
So have a think about this. Have a think about this. You said divide both sides by 3, and you'd be left with a equals 4. Okay? Imagine I couldn't do division, but I could do multiplication. Could I rewrite that, so dividing by 3, could I rewrite that in terms of multiplication? What could I multiply by? By the inverse of 3, yeah? So we're happy with that. If I divide by 3 on both sides, that's the same as multiplying by the inverse of 3. That's the same as multiplying by the inverse of 3, or multiplying by a third, okay? Okay, you happy with that? Yeah, so I've multiplied both sides by the inverse of 3, and then I'm left with a equals 4. Okay, so let's try and use that same kind of inspiration here. So what I'm going to do, just scooch that over a little bit. So I've got 15 and I've got 0. Okay, I'm going to try and use the same kind of idea here then. I'm going to try and use the same idea here. So what do I want to do? I want to multiply by the inverse of this matrix here. Because of course if I multiply by the inverse of this matrix here on both sides, then I will just be left with xy equals some matrix. So let's see this in action. All right. What would the inverse of 1, 2, 2, negative 1 be? How do I calculate the inverse? Anybody remember? How do I calculate the inverse of this matrix? Okay, yeah. So 1 divided by the determinant of this matrix, which will be equal to?
-1 -4.
Good. 1 times -1 is -1, and then I'm minusing 2 times 2, which is 4. So -1 take away 4 is -5. So it's going to be -5. Okay. And then what do I do to the elements in this matrix here? What do I do to the elements in this matrix here? So I swap the leading diagonal around. So 1 and -1 swap places. What do I do to the other 2 elements? Good, I make them negative. All right. Now I'm just going to tidy this up slightly, just because I can. In fact, am I? No, do you know what? I'm going to leave it like this. I could multiply through by -1/5 if I wanted to, but you know what? I'm not going to bother. I'm not going to bother. Okay. So what I'm going to do now is I'm going to multiply both sides by this matrix here. So I'm going to multiply both sides by -1/5 of -1, -2, -2, and 1. Okay, so this is my inverse matrix. -2 and 1. You happy with that? Yeah? It's exactly the same as what was happening up here. Okay, so don't lose track of that. All right, okay. So now all I need to do is just think about what I get. Now all I need to do is just think about what I get. So are you happy? On the left-hand side, I've got a matrix, and I'm multiplying by its inverse. Okay, so my matrix is in red, my inverse matrix is in black. So what is that bit equal to? Just the identity matrix, right? If I take a matrix, multiply by the inverse, that's just equal to 1, the identity matrix. Okay, so on this side, I just end up with 1, 0, 0, 1. Still got that, so I've still got xy. Okay, but then what do I get on the right-hand side? What do I get on the right-hand side? So what's this multiplied out? Let's do it then. Negative 1 times 15 plus negative 2 times 0. So what I'm going to do is I'm just going to leave the negative 1/5 till last. So actually I'm just going to stick him here. All right. What is negative 1 times 15? Negative 15. Negative 2 times 0 is 0. So negative 15 just goes there. Happy with that? Okay. Then I'm going to have negative 2 times 15, which is negative 30, plus 1 times 0. So negative 30 goes there. You happy with that? Yeah, I'm taking a 2 by 2 matrix, multiplying by 2 by 1, so I should end up with a 2 by 1 matrix there. Then all that's left to do is just think, right, if I multiply through by negative 1/5, what do I get? So negative 1/5 of negative 15. 3, right? Do you agree with that? It's just 3. And then what's negative 1/5 of negative 30? 6. Fantastic. Okay. And are you happy that if I multiply this side out, so 1 times x plus 0 times y is just x, and 0 times x plus 1 times y is just y, that there is my final answer. That there is my final answer. Okay, that's my final matrix, which is what I'm after. Because now I can just read off that x is equal to 3, and y is equal to 6. So those are my solutions. Those are my solutions there.